to continue along our solving equations lesson. Hey guys, we're starting. Sorry. 1.5, I think it's C now. We're going to talk about rational equations. Now, we talked about rational expressions, but when we talked about rational expressions, we added them, subtracted them, multiplied, divided them. Now we're going to talk about what happens when our equation involves them. Now, this is sort of like the pretty neat thing about mathematics, is that if you learn one or two few skills, they together allow you to accomplish other things. So rational equations does not introduce any new ideas. It utilizes a whole bunch of different aspects that we've already talked about. So some prerequisites that we need to know. And the word prerequisite means, like, how do you define prerequisites? It's sort of like the foundation stuff that we need to be adept at. We need to be able to solve linear and quadratic equations. Yes, rational equations are nothing more than linear and quadratic equations in disguise. We need to be able to factor. That's sort of like the one key skill in all of mathematics, to be able to factor. We need to be able to find the least common denominator of polynomials, right? Finding the LCD of numbers is a nice skill to have, but finding the LCD of polynomials is a critical skill. Assuming that we have all these prerequisites, congratulations, you have the skill sets needed to solve rational equations. Now, if you were to do independent research and go into Google and type in how to solve rational equations, you're probably going to read a whole bunch of different methods out there, because there are lots of different methods out there. I'm only going to talk about my personal favorite one because I think it's a lot easier to understand and, in my opinion, it's a lot faster. That technique that we're going to employ is clearing the fraction. Yeah, I know, I sound a bit biased. I use clearing the fraction a lot. I mention it whenever I can, simply because it is a gosh darn versatile and useful technique. Clearing the fraction, also known as clearing the denominator. If you forgot how to clear the fraction or clear the denominator, you find the least common denominator. You multiply every term by the least common denominator, and then you solve the resulting equation. That's how you solve a rational equation. Just get rid of it. I know people don't like fractions. That's what rational expressions are. So let's just get rid of it by clearing it. And then once you clear it, you use your prior skills of solving equations in general, be it a linear equation, a quadratic equation, cubic equation, what have you. Right. So let's see this technique in action with an example. Suppose I ask you to solve. Actually, before we solve, I forgot one more bullet point. And I'm not going to use a bullet point or a dash. I'm going to use an asterisk. Right? This is only special for rational equations. Yesterday and the days prior, when we solved equations, whatever answer we got, that was our answer. We were happy with it, if you trusted your math skills and your arithmetic skills. Rational equations do have their own extra layer of complexity, in that you must check your answers. I didn't make you check your answers for linear or quadratic equations because the domain of those functions are all real numbers. But when it comes to rational expressions, fractional expressions, we have to safeguard against the one thing that your probably third grade or fourth grade teacher taught you when you first learned about division. You must check your answer against dividing by 0. So rational equations will be different from any other problem types we've talked about this year, in that you might have to throw away some answers if it forces you to divide by 0. But other than that, the techniques are the same, the logic is the same, the inverse operation is the same, yada, yada, yada. Let's take a look at an example here. Suppose I ask you to solve 3 over x minus 2 over x minus 3 equaling negative 12 over x squared minus 9. That's an example of rational equations, fractions everywhere. This looks like a hard problem. So what do we do with hard-looking problems? We rewrite it so it's easier. So this will be sort of like my scratch work area. So what I want to do is find the LCD. So let's go through the process in case you forgot how to find the LCD. The first thing I'm going to do is write down the denominators vertically. So I have a denominator of x minus 3, denominator of x squared minus 9. The next thing you want to do is factor everything. There's nothing you can do with x, so it stays as x. There's nothing we can do with x minus 3, so it stays as x minus 3. And notice how I'm writing with the parentheses, because the x minus 3 together is the whole factor. And then x squared minus 9, of course, is the difference of two perfect squares. So the LCD, you look vertically, not left to right, but you look up and down for any common factors. And in this example is pretty obvious. The x minus 3s are in common. You keep looking up and down for common factors. We have no more common factors. So you have to put any factor that you did not circle. I always like to put monomials in front, though. So there's my LCD, x minus 3, x plus 3. As before, when we did our rational expressions, I will suggest you guys take the extra 2 lines on your paper, take the extra 10 seconds out of your life to rewrite the problem. But rewrite it with some space and rewrite it with the denominators factored. So I'll go ahead and rewrite the problem. 3 over x, leave some space, minus 2 over x minus 3, leave some space, equals negative 12 over, and I'll rewrite the denominator in factored form. Once you get better at these, you can actually skip this step. I personally do because I can do it in my head, but I suggest you all keep writing it out until you get super duper good at these. Once you have once you rewrote the problem, the technique is to clear the fraction, multiply everything by the LCD. So the first term gets multiplied by x minus 3, x plus 3. The second term gets multiplied by x minus 3, x plus 3. The last term gets multiplied by x minus 3, x plus 3. Right. This is the logic. This is the whole reason why we multiply by the LCD. By definition, the least common denominator contains every single factor in the denominator. So there should be a whole lot of cancelization. In fact, all of the denominators should cancel out. The x's cancel out in the first fraction. The x minus 3's cancel out in the second fraction. And both the x minus and the x plus 3 cancels out in the third fraction. I would usually then at this stage distribute, but I'll go ahead and rewrite the problem to clean it up just for the sake of notes. So let's just write down what's left over. What's left over in the first fraction is a 3, x minus 3, x plus 3. What's left over in the middle is a minus 2, x plus 3. And what's left over on the equal sign is just a negative 12 and an x. We've done it. We've cleared the fraction. No more denominators. You just solve it like a regular equation now, a regular linear equation, a regular quadratic equation, whatever it is that you have. Can I assume we can fast forward through this? Okay. So I'm going to distribute, get rid of these parentheses. So the x minus 3, x plus 3 is an x squared minus 9. Distribute the minus 2x's. Remember to distribute that negative as well. So it's a minus 2x squared minus 6x. So we get a 3x squared minus 27 minus 2x squared minus 6x equals negative 12x. I see I have x squares, so it's a quadratic. The technique to solve a quadratic is to get 0 on one side. So I'm going to add the 12x over and combine like terms. So that gives me an x squared plus 6x minus 27 equals 0. So then you go ahead and use yesterday's skill sets. To solve a quadratic, you can factor him. If he's not factorable, use completing the square. If you don't want to use completing the square, use quadratic formula. Hopefully I picked this example and wrote it down correctly enough so it's factorable. 3 and 9? Yep. X plus 9, x minus 3. So we get x equals -9 and x equals 3. If this was our original problem, those are solutions. We go home and be happy. However, that was not our original problem. Our original problem had denominators. So we have to check our solutions against the denominators. So just to remind ourselves, our denominators were x minus 3, and x minus 3, x plus 3. Notice I don't really care about the numerators. I just care about the denominators. Question. I just added the 12x over. Because to solve a quadratic equation, you need 0 on one side, so you move all the terms over. Yep. So just go ahead and check, plug these x values in, and if any of those x values forces any of these denominators to be 0, you have to throw them away. Which x value must I throw away? We must throw away x equals 3. Because x equals 3 will make this guy and this guy equals 0. And since they're denominators, they can't equal 0. So we have to throw this answer away. This problem only has one solution, x equals -9. You guys understand what I mean by checking against the denominator? Mm-hmm. Right. You don't want the bottoms to be 0, so just do a quick check against the denominators. All right. Now, the example that we just did was just a generic rational equations. Notice that here's the beginning of the problem. It had 3 pieces: this piece, this piece, this piece. If your rational equation only has 2 fractions, that is to say, one fraction equaling another fraction, it's still a rational equation, but it's a special type, so we give it a special name. We call those proportional equations. I'm only talking about this more for the vocab than for the actual skills. To solve a proportional equation, it's still clearing the fraction, but in the context of proportional equation, we don't call it clearing the fraction, we just call it cross multiplication, right? So clearing the fraction is the same thing as cross multiplication for proportional equations only. And again, proportional equations are equations that look like one fraction equals one fraction. Right? If it has more than 2 pieces, if it's more than one fraction equals one fraction, technically it's not a proportional equation. So let's see this in action really quickly, just as a quick example here. 2x minus 1 over x plus 2 equals 4/5. One fraction equals one fraction is proportional. So the idea of cross multiplication, you take the numerator of one fraction, multiply it with the denominator of the other, take the denominator of one fraction, multiply with the numerator of the other. A common mistake I see students make when they cross multiply is they do something like this. So I'm going to erase it so I wouldn't copy it down. They go, okay, I'm going to cross multiply equals whatever answer I get for my yellow, I'm going to divide it by whatever I get for the blue. They create a new fraction, which is wrong. The act of cross multiplication is to get rid of the fraction. So when you cross multiply, you set your answers equal to each other. You do not create a new fraction. So it'll be yellow equals blue. So if I cross multiply, this should give me 5 times 2x minus 1 equals 4 times x plus 2. So cross multiply, you set them, you set them equal to each other, not divide them. And then it becomes a regular linear equation that you can solve all day long. 10x minus 5 equals 4x plus 8. Subtract the 4x, add the 5. 6x equals 13. X equals 13/6. It's still a rational equation, so we have to check against the denominator. We only have one variable denominator, which is right here. It's going to be an obvious question. 13/6 plus 2, is that 0? No. So we keep this as a good answer. Right. So if you have a proportional equation, you can cross multiply if you want. But if you have more than 2 fractions, the one technique you can employ is clearing the fraction. Any questions? So that's rational equations in a nutshell. All they are linear and quadratic equations in disguise. Once you clear the fraction, use all techniques. That is 1.5.
Is that it?
That's it.
Stretch out or what?